G'day viewers, Alan here. Welcome to my workshop, and I might say I'm quite pleased to be back into it. I actually got wiped out by a rather nasty respiratory virus. It took me out for most of December. I really just didn't feel like coming out to the workshop, so I haven't really done anything probably since late November. Anyway, Christmas has come and gone, and the sun has come out again for me, so I'm back in the workshop. And I thought I'd ease back into it by making a couple of the pieces that I've yet to do for this motor. So one is an inlet manifold for the carburetor, and the other some sort of bracket to hold an idler pulley for the cam belt. I don't have drawings for either of those pieces, so I've got to come up with something myself. So let's get at it and I'll show you how I went about it. So when I first tried to install the cam belt, it was really tight and I wasn't happy about that at all. So I actually bought a next size belt up, but when I put that on it was way too loose. Then I realised that the reason that I was having this problem was I'd actually made a cylinder head gasket which wasn't allowed for in the drawings, and it's definitely got some thickness here. It's 0.8 millimeters thick, that gasket, and that was enough to mess it up. So I took the gasket out and then found that the original belt in fact was about right, but it did still want a tensioner. But unfortunately I never received a drawing for the tensioner, so I had to make something up. So what you can see here is a prototype design, just 3D printed in plastic. So you can see it more clearly with this earlier draft. It's basically 4mm thick flat piece. I'll make it out of aluminium with 3 holes, 2 to mount it to the crankcase, and this third hole is for the pivot bolt. And it's an interesting thing to machine actually, because we've got an angled edge here, angled edge there, and a curve at the bottom. It's a bit tricky working out how to hold it. But I've come up with something that works, so we'll go over to the milling machine and let's have a look at that. So I chopped a piece off the end of 50mm wide bar stock, 6mm thick, to give myself a bit of material to play with. And as you can see, that's the bit that we're trying to make. So because I need to machine all around it, I decided to mount it on a bit of scrap. So I drilled that bolt pattern through and did that mounting. So just explaining how I've worked out the hole positions. If you have a quick look at this drawing, I actually established a datum point out here, which is the rotation point for the curve that I need to, clearance curve or arc I need to cut here. So I worked out all of my hole locations and everything else away from this datum point or centre of rotation. So now I want to get the boring head set up to do that curve. We'll start off by presetting the diameter. I've clamped a block to the table, just used a square to set it square. So now I'll use the edge finder to find that face. So that's 10mm diameter, so we'll allow for that and set a 0. Now I know where that face is. I've offset the table 24mm, the required radius. Put the boring head in and set the cutter, and so I can adjust the diameter of cut now, or radius of cut, and when the boring bar just leaves a witness mark on the face of that thing, I'll be pretty darn close. Remembering that I'm only trying to do a clearance arc here, not a bearing fit, I think that's going to be good enough. So let's see what happens. Getting very close now, so I'm just stepping at 0.01 off the diameter. I think that's just touching now actually. I can hear something but I can't see anything. Anyway, you get the idea. I'm going to get the camera out of the way so I can have a proper look at what's going on. So the amount of material that has to come off in the middle here, which amounts to the depth of cut, is 2mm. So I'll actually cut it out with 2 passes. about 1mm each. So I'll bring the centre of rotation of the cutter back towards me by 1mm for my first pass. So that instead of that being on the 0 point, I'll bring the wire towards me by -1. Take our first cut at that. Now I need to set a stop, a hard stop, so I don't shoot into start trying to machine the vise. Right, I think we're good to go. First pass. Well, that looks like it's in the right place. So we'll come back to the correct position now. Alright, let's do the second cut. Well, that looks pretty good. I did think about making up a test piece, just turning up a disc with a 48 diameter, 48 diameter, just to test that. Well, as it turned out, I remembered that I had a piece of pipe which was about the right size. It was about 48.1 or 2, so it was very easy to turn up a ring that was the correct OD and use it as a size gauge. And you can't see, you'll have to accept my assurance that that curve is extremely close, but if anything it's slightly larger than 48, which is exactly what I need, because if it was smaller it might not fit on. So happy with that. Now I need to work out how I'm going to do these other features. So I might as well start with the easy bit and chop this end off. So I left myself a 0.1mm clean up pass to do there. Alright, got to reposition to do these other cuts. Well, since the outside lines don't contact with anything, they're just clearance and to look nice, I decided to just mark around the plastic piece prototype and use those lines. So I think they show up alright. So I'm going to rough it out with the old hacksaw and then take it over to the milling machine and clean it up. That's the plan anyway. That's one piece away. Left myself a millimetre or so to clean up. So now do this other cut. Right. I might as well cut a bit off across there as well while I'm at it. Okay, well, let's clean the long side up and see how that goes. Right, that seems to have cleaned it up to the line pretty well. Happy with that. Turn it around and do the other sides the same way. So now I want to rough out this curve here, which I think will just show up. And I'm going to do it by taking slices and rotating this around. So it doesn't matter where we start. I just have to get the depth correctly set. Okay, it should be 5 clear of this, and that's 5, so basically 10 above that. So let's see what 10 above that looks like. Alright, so there's 10. I'm going to zero the quill DRO at that. We'll go in at 0.5 millimetre high. Let's see how that goes. Okay, we'll do another one to get a cross reading on that before I commit to doing it at the 10. Let's try that. I think you see that's working out alright. I'll do one more cut and then get the camera out of the way so I can do it without falling over myself. Alright, so that looks like it is in fact clearing by about 0.5 millimetre, so we'll go all round at that, I think. Okay, so I've been all round it once at 0.5 millimetre high, and it's doing a really good job. It's the first time I've seen others use this technique, but it's the first time I've actually tried to use it. And you can see all the little flats, but they'll clean up, I'm sure, very easily with a bit of emery. Anyway, now I can see exactly how it's going. I'll come back with the full depth. So I've been all around it now, and you might just be able to see the faint remains of the witness line, the line I was following to. Anyway, I'm quite pleased with how that turned out. So now I've just got to give it a quick go with some emery paper, and that's finished the body of this thing. Right, well I think you can see it actually fits perfectly. I'm very happy with that. That matches the curve on this front piece of the crankcase perfectly, and the screws lined up perfectly as well. I've given it a quick rub with emery paper and just cleaned these curves up a little bit. No point getting carried away with that though until final assembly. Alright, so with that done, it's time to make the stub shaft that this pulley will sit on. This is the diameter which will hold a pair of bearings. The bearings mic at exactly 5. To get the firm slide fit that I want on there, I'm shooting for 4.99. And so I'm trying to sneak up on it at the moment. My last pass was at 6 millimeters, so I'll do 5.5 this time, and we'll see what we get. .503. We go for 499. Five dead. I was looking for 499. So now I've got a dilemma. Do I do another cut, or do I just attack it with a bit of emery paper? I think we'll give the emery paper a try first. So we're shooting for 499, or at least somewhere between 499 and 5. I think maybe you can see we got 4995. Alright, so let's see how this feels. It definitely slides on. I think it's probably pretty good actually. Might have been nice if it was just ever so slightly tighter. But that isn't moving around. So I think that'll be alright. Alright, so I better cut this bit off the end here. That was just there because my tool couldn't reach in far enough with the point. So next thing is remove the lump on the end and drill this out and tap it for 3 millimeters. I think we'll rev it up a bit. Yeah, 1300 to go. And we want to go in 10 millimeters. Okay, so I eventually found the 3mm taps after playing another long round of Hide That Tool. I'm sure you've all been there. Time to empty the chips out, I think. Not an awful lot of room in an M3 hole. Alright, let's see if it works. That's a nice fit actually. The screw in the end, and the head of the screw is going to be the retainer. I could put a washer there, but there doesn't seem to be any point. Double Loctite on that when the time comes. Okay, so now I turn this round in the chuck and then machine the other side. Yeah, I was getting ahead of myself. I need to part this off before I can turn it around. It might have a little bit of warmth in it, so we'll treat it with respect. Right, I'll bring it back when I've got it all turned around and set up again. Alright, doing the final pass now to bring this down to 5. .502. Well, I guess what counts is whether or not this will actually fit over it. Oh, that's a really good fit. Yeah, that's bloody perfect. Great. And I didn't explain it before, but there's a recess here, 1mm deep, 8mm diameter. And the purpose for that actually is twofold. It allows me to put a nut on the back of this and have something to do it up against, so that's important. But actually there's another reason. If I find out that the positioning of this in this bracket isn't quite right, I can make another one of these and offset the boss on the other side, so that as you rotate it in here, it changes the offset. So that's the backup plan if I haven't quite got this right. But I'm pretty optimistic it's okay. Anyway, so what I've got left to do now is put the 5mm thread on here, up to 3mm away, because obviously there's no point having thread going inside there, I don't want that. Okay, I'll get set up for doing that. Alright, I think that's it. Let's see what happens if we try doing that. I might rip this out of my hand, we'll see. I think we're going to call that it. When that nut goes on, that'll press that on. I don't really want it to be loose anyway, so we'll call that done. Actually, the nut pulled that in there just nicely. I'll be replacing that nut with a lock nut in due course, nylock nut. So that's all looking good. I'll go and put it on the engine and see if it works. Alright, so I've got it all together, all fitted perfectly actually. I think you can see it's doing the job it's meant to do. It's just got a gentle side pressure on the belt. So I don't think I mentioned earlier, I think that I could, if necessary, change this stub axle so the pin on this side is offset to get some adjustment, but I don't need it. The beauty of doing the plastic prototype was I was able to work out exactly where to position it. So it's another piece of the puzzle. Quite happy with that actually. So next cab off the rank is carburetor, I think. So for this model I actually bought a carburetor. The Vapor carburetor worked quite well for the Webster engine, but for this one I've lashed out and bought a carburetor. And for anybody who's interested in the detail, it's a 6mm bore and TRX Pro 15. So the mounting of it is the next challenge. So that just has a smooth 10mm diameter boss. So what I'm going to do is make up an adapter. I think you'll see that goes in there quite nicely. So that's my 3D print prototype, so I need to make one of those out of aluminium, and then I think I'll just push that in there with some of the weakest Loctite I've got, and I think that should be fine. And I've checked I can actually get at those screw heads once the carburetor's on. So let's get into making this and get on to making an aluminium version of this. So I've got a piece of 33 diameter 6061 bar in the chuck, and we'll do the round bits in the lathe and carry it over and do the square bits in the milling machine. So first up, face it off and turn the OD down to 12. So let's just see what we did land on. I'm going to be happy with that. Right, so that's the external, well, the start of the external features. So the next feature is to take this in this area here, 3 away from that face, take that diameter down to 10 from the 12 that it is at the moment. So we'll do a couple of plunge cuts with this to start with. So I've got the top slide set to 24 degrees, and this feature on the outside is cosmetic, so as long as it looks roughly like what I was expecting to get, that'll be good. Before I do anything else, let me just check the diameter there. I've got a little bit of scope there. Alright, so I can do one more pass, final clean-up pass. Well, that looks pretty good. I'll call that done for those exterior features. So now I've just got to put my hole through the middle. That's the 8mm drill. I've got to go in for a depth of 18. That should be fine for that. Just cover your eyes for a minute. So now I need to open this out to 10mm and for a depth of 8. And I was going to just use a slot drill, but I suppose I can set the boring bar up and then I've got more control. It's supposed to be 8. I'm pretty sure it'd be bigger than that. Yeah, we've got 0.18 over. Alright, so we've got to touch off with the boring bar. Right, and we'll say that's 8.18. Let's see how close that is to 8.5. I don't know whether you can see that. It's pretty close. That's not bad for a first pass. So the dimension doesn't matter now so much as whether or not this one is right. Oh, yes. Let's just deburr the hole. That would easily push on, but I don't know how much clearance I should really have for the sealer that I'm going to use, or whether to, yeah, because I think it'll need sealer. Let's just do a spring pass at the same setting, which is I don't think would take very much off. Right, let's see how that goes. Ah, that's perfect. Yep, just a nice allowance for the bit of Loctite. Yep, happy with that. Right, so all that's left to do for the lathe work now is part that guy off. Very happy with this parting tool, it just seems to work really well. Alright, clean up time. Right, over at the milling machine, so it's all going very well so far. So obviously what I have to do now is cut that rectangular pattern onto that. And I did my best just now to snatch defeat from the jaws of victory. I put that in there. And I just started to tighten it up and I thought, oh, there really isn't much material to tighten it up against. And even with the little tightening that I gave it, it did actually close this up a little bit. So I've made up a slug. I made up a slug to go in there. It's a pretty firm fit. And I'll make sure I put it in square. And then I'll be able to tighten the collet up against it. So I'll just go and get this put in square. So I'll be able to do the collet chuck up tight now. That should be good enough. And these might still have distorted things a little bit, but I think it'll be alright. Well, I hope so anyway. Right, so I'll get started with the milling cutter and find my edges and come back when I'm ready to start milling. Alright, ready to go. I centered the hole under the quill and called that 00. So all of my measurements are from that datum point. So I've got slices on 4 sides, and I'm a bit wary of just how well this is gripped in the collet chuck. It should be pretty good, but this spinning around might try and rotate this a bit, I suppose, but let's hope that doesn't happen. I'll take light cuts. I just thought I'd show you while I'm cutting this side and you can see it properly. This end mill is throwing off a pretty impressive stream of chips. So I finished up all 4 sides and actually finished up hitting this one exactly on 13, but more importantly it actually feels like a very good fit in its space where it has to go. So now I've got to do 4 2.5mm holes. So, having done the 4 holes, this is ready for a test fit. And I don't think it needs to go back into the lathe, so I reckon I can take it out of this now. Just have to knock that filler plug out. Alright, so how did it finish up? Well, I'm quite pleased with it. Well, it looks the part. Anyway, my hand will get in the way I expect, but I think you'll be able to see that it's a really nice fit there. Turn it around and make sure screw holes line up. Yep, these are away. These off. I see. Just so I'm not sexist, maybe this last one's a girl and she's off. Alright, so now the big question. Now I'm not going to put this together with Loctite at this stage of the business, but yeah, nice. Alright, carburetor mounting ticked off. I'll put the Loctite in when I do final assembly. So as far as machining goes, now I've got the idler and the carby done, the only thing left from a machining point of view is sorting out the ignition timing. And I'm not sure yet how to do that. I've got a Hall effect sensor. The drawing, the only drawing I've got that from Greg that shows me anything about timing, shows a disc here somewhere. But there's not an awful lot of room there, and I know the original version of this engine, the camshaft was double-ended and the timing gear was on the end here. I have spent a bit of time thinking about whether it's possible to put the disc in there, and if it is, I'll go down that path. Otherwise I'll have to make another camshaft with a tail sticking out the back. Anyway, that's the next step. Well, that's taken me a couple of steps closer to a finished engine, and I think those bits turned out pretty well. So I think I already mentioned that the major piece outstanding now is the ignition system and some way of dealing with the Hall effect sensor, etc. I've got a kit of parts, so I've just got to scratch the old head, get some splinters and nut out how to do it. So that'll be for the next video. So I hope you enjoyed this one, and in any case thanks for watching. So hope to see you next time.